Hello. In this video, we're going to go ahead and look at some properties of the parabola. Now, in this section, we're going to be looking at how we graph quadratic functions. So the graph of a quadratic function is just a parabola, and you've got three of them graphed here for you already. Okay, so here's the thing. Parabolas are basically just U-shapes. They either open up or they open down. That's pretty much it for parabolas. Now, it's not really a U, but you can think of it as a U. So if it opens up, we have, first of all, it's a quadratic function, right? So quadratic functions are in the form of f of x equals ax squared plus bx plus c. This a here is the leading coefficient of this general form of a quadratic function. So in order for the parabola to open up like this, we're going to need to look at a. If a is positive, the parabola opens upward. If a is negative, the parabola opens down. Also, if a opens up, there is a minimum point, and if a opens down, there is a maximum point. So that leading coefficient is extremely important here. It tells us a lot of things. It tells us if the parabola is opening up or down, and it tells us if we have a maximum or a minimum for the function itself. Now, the maximum or minimum is called the vertex. And the vertex has a particular coordinate in the function, and it all depends on what a and b are. Notice it actually does not depend on, well, it kind of depends on c, but the x-coordinate does not depend on c. So the vertex for a quadratic function is the following. It is the coordinate negative b over 2a, comma, f of negative b over 2a. And this is important, and what's most important out of all this is the fact that negative b over 2a is the x-coordinate, because if you can find the x-coordinate, you can just plug it in for the x values, simplify, and you get the y value. That's all this means, is the function value at the x value. Wonderful. Next, let's look at what we see as axes of symmetry. Now, every parabola has an axis of symmetry. In this case, parabolas have vertical axes of symmetry that goes through the vertex itself. So looking at these two functions, we have an axis of symmetry here and another one here. Now, I'm drawing these as vertical dotted lines because these technically aren't part of the graph itself. These are just something to help us. Now, we have a vertex here, we have a vertex here, and we have a vertex here. So here, here, and here. Notice that this happens to be the exact same vertex for both of these two graphs. The reason why is because the x value is the same for both of these. The y value is different, but that doesn't matter. Because remember, the form of a vertical line is x equals a number. So the equation of an axis of symmetry is in the form of x equals some number. And in this case, that means that it is negative b over 2a, whatever you got when you first found that. In other words, it is the x-coordinate of the vertex. So that's what's written right there. Wonderful. Now, let's talk about domains and ranges. So for domains, for every single parabola, the domain is all real numbers negative infinity to infinity. And the reason why is because we're missing one of the two things that limit our domain. At least one of the two things so far. And those things are rationals and even indexed radicals. Rationals meaning fractions, basically. So because if you look over here, there are no fractions, at least no fractions with x's in the denominator, and no square roots or fourth roots or anything like that. Therefore, the domain is going to be all real numbers. As a result, that means that all parabolas have a y-intercept. Every single one of them. Because the only thing that you need in order to have a y-intercept is to cross the y-axis. And since the domain is negative infinity to infinity, there's always a value at x equals 0. So every single parabola has a y-intercept. However, not all parabolas have an x-intercept. In other words, only some parabolas have x-intercepts. And if you notice, for the purple graph here, there are 2 x-intercepts. And for the blue graph, there's only 1 x-intercept, and that 1 x-intercept happens to be the vertex. And so if that happens, if you only have a single x-intercept, that single x-intercept will always be the vertex itself. In other words, the y value for the vertex will be 0. Notice, though, that for the red function, or the red parabola here, it never crosses the x-axis. That means that it does not have an x-intercept. If you were to set the function for the red function that we have here equal to 0 and solve, you would get imaginary numbers out of it. Excuse me, non-real complex numbers. And what's going to happen as a result of that is that means that there are no x-intercepts. Awesome. Now, let's return to the domain and range. Let's talk now about range, because the range is interesting. The range depends on, well, several things. First of all, the range is always going to be limited. What I mean by that is that it's not going to be negative infinity to infinity. Notice that this blue curve, it'll go down towards negative infinity and then all the way up to this y value of, well, 0. But it stops at 0. It cannot go any higher than 0. Or this red function, it goes up towards infinity, but it comes down here towards the y value of 3 and then goes back up towards infinity. In other words, it can't go any lower than that 3. And the same thing for the purple function, it can't go any lower than negative 3. And it's opening up. So notice that if the function is opening up, you have a minimum y value, but if a function is opening down, you have a maximum y value. So for the range, it depends on what a is. So for the range, the y value of the vertex, now I'm going to call the vertex h comma k, and it'll make more sense a little bit later on. So for the range, the vertex, if the parabola's opening upwards, the vertex is going to be k comma infinity, including k excluding infinity, because we always exclude infinity, given that a is positive. In other words, the leading coefficient is positive. If the leading coefficient is negative, it's going to be the following. It starts at negative infinity and goes up to that y value, with a square bracket. And that happens when the leading coefficient is negative. So this leading coefficient is telling us a lot here. It's telling us whether the function is opening up or down. It's telling us if the vertex is a minimum or a maximum. It's also telling us what the range is going to be. Is it going to be going up to infinity if it opens up, or does it go down towards negative infinity if it opens down? So it's going to be one of these two. And also, a is part of the vertex as well. Not the entire thing of it doesn't really determine the vertex entirely, but it does play a role. And the same thing for the axis of symmetry. So that leading coefficient is very important here. Alrighty, well, I believe that's it for this particular video. I'm going to go ahead and leave it here, and I will see you in the next one. Have fun.